Okay, so it's using the tablet microphone, whatever. Let's unhook that so maybe it will sound better then. Okay, so 4.4 is going to be counting rules. So your main counting rules, or all your counting rules, are fundamental counting rule, permutation rule, and your combination rule. So let me get to the right section too. So the first thing that we're going to do is the fundamental counting rule. I was going to get my mouse and see if my mouse works better up here. So your fundamental counting rule, no, that's totally in the wrong place. So maybe it won't work over here. Okay, is that worked really fast. In a sequence of events in which the first event has however many possibilities, we're just going to label it that, and the second one has the next little label, the third has that many, that can go on forever. The total number of possibilities, I didn't even click anything. Okay, whatever, are found by multiplying the number of events together. So if I had like 5 here and 4 here and 5 here, or whatever they are, I'd have like 5, I don't remember what I said, 5, 4, 5. Okay, so I would just multiply those 3 numbers together. Okay, where that's actually helpful is so that we don't have to go through and list everything and actually be like, okay, there's like 1, 2, 3, 4, oh, there's 12 of those things. We don't want to have to list that many things. Okay, because that just is kind of a pain in the butt, how many things we've had to be listing, or making a tree diagram to make everything just kind of gets crazy after a while. Okay, so to actually use the counting rule, it's way simple. And you guys have probably done it in the past and are probably already used to using it a little bit. So, I never know if I've actually clicked it or not. If I flip a coin and roll a dice, so how many choices are there for flipping a coin? 2. How many choices are there for rolling a dice? 6. Multiplying those, how many total choices would I have altogether? 12. Okay. Remember, like the last time we did was sample spaces, where we would say, okay, I had to have heads 1, heads 2, heads 3, heads 4, all the way. Then I would do like tails 1, tails 2. Okay, and then after all, I'd get 12 total things that I could count. Well, if I don't actually care what those things are, I don't need to list them all. So we're just going to use this counting rule to figure out, oh, out of how many did I possibly have? So that's where it's actually useful. Okay, so without the fundamental counting rule, you'd have to use ginormous gross tree diagrams. So this is a good example of where it would be a really gross tree diagram. I don't really want to say, okay, I could have red, I could have blue, I could have white. I don't want to do this. This is gross. And then from red, then I could have latex or oil. From blue, I could have latex or oil.
I think you're gonna have flat, semi-gloss or high gloss.
Yeah, and then so.
And then outdoor and indoor.
So then each of those would have those little things. That's gross. We don't want to do that much work.
Well, it makes a really cute little tree.
Yeah, see, that's why we call them tree diagrams. They do get like cute little trees after a while. Okay, we don't want to do that. That's gross. We're just going to say, hey, from that color, we have 1, 2, 3, 4, 5, 6, 7. So we have 7 choices times 2 choices times 1, 2, 3 choices, and outdoor, indoor times another 2 choices. So I'd have 14, 84. So I'd have 84 total choices then. Okay, where'd my little pin go? Okay, so it's way easier than that other gross stuff was. Okay, so now if I wanted to do like ID cards, the store manager wanted to make 4-digit ID cards, so 4 digits important for her employees. How many different cards can she make if she uses the digits 1, 2, 3, 4, 5, and 6? And repetitions are permitted. So those are kind of keywords that you're going to start looking for.
So like 6 times 4 would be like 24.
So you think only like 24 choices?
No.
We could probably list more than 24 choices.
So if it's 4 digits.
Yep, so I'm going to have 4 spaces to fill out. How many choices do I have for this first thing?
4.
How many digits can I use?
6.
I can use 6 digits.
Times 5.
How many digits can I use for the second digit?
6.
Oh no, so I thought they had
Still
to be a different
6?
number.
Yep, so make sure that's where, like, things, repetitions, you're looking for those words. I could have 6 again. I could still have 6 choices. So 6 to the 4th, basically, so I think 1296. I have it somewhere right here.
Marijuana made over
Yeah,
made
1296.
almost $1 billion in Colorado in 2015.
Nice. I wonder what's going to happen to that money, too. Where is that?
Apparently bad things.
It's 1296.
Because it's a gateway drug, you know?
Okay. So, oh,
And I'm just
look
gonna
at
start
that. I
doing
have it
them
all
now
typed
because
up. That's so nice of me. Okay. So, the weird thing that we're going to do, I don't know why I talked about this one on this slide. If repetitions are not permitted, the first digit would have those 6 options. Then I'd have 5 options. Then I'd have 4 and 3 options. So that gives me that 360. So we're going to talk about those different types of things when repetitions are permitted and when repetitions are not permitted.
Do we have to go into depth? Because I understand it right now. And
They
now
have
you're gonna
gross
go into
formulas.
depth, and that's gonna confuse me.
Okay, and then what else we're going to talk about is whether order matters eventually. Okay, so right here, this guy is what we call permutation. If repetitions are permitted and okay, and 360 if they're not okay. Okay, so now we're just going to talk about what are factorials. So some of this piece here is the start of a factorial. So a factorial looks just like an exclamation point. And so if I said 5, like exclamation point, it would really mean 5 times 4 times 3 times 2 times 1. Okay? So 10 factorial, so you can start at whatever you want. Your calculator does it. It gets kind of crazy after a while, and it'll eventually just start saying, no, we are not doing that actually. I'll show you where to do it on your calculator. The gross definition is this thingy. Main definition to remember is that 0 factorial is equal to 1. And what that's going to do later on is keep us from dividing by 0, because that's get gross. Okay, on your calculator to find your factorial button and these other 2 buttons that we're going to use a lot today, you click your math key, which is on that left-hand column, and then you have to go over to like PRV, which is for probability.
So you have to hit what?
Math.
Nah.
Math.
Whoa.
Math, and then you're going over
And
to
then
PRV.
And then to PR.
Perb. You perb.
And then down to 4.
Okay. And then what we're also going to use today is this NPR and NCR. We're not going to use it in the calculator, but I want you to know where they're available at, so when we do them.
Do you have to like put it in parentheses? Or do you have to put the number then the
Yeah.
thing? Oh.
Yeah, so I mean, it always has to come right afterwards. Did you get one to work? I didn't actually multiply any of them out.
Oh my gosh.
Got it now.
Okay.
You want
That
a
was-
trophy?
Participation award.
Don't get me started.
Suppose a business owner has a choice of 5 locations in which to establish her business. She decides to rank each location, so ranks are something that we'll talk about and why that's important. According to certain criteria, we don't need to know any of that stuff.
Why?
We don't care about the price of the store, parking facilities. She's just ranking it randomly as far as we're concerned. How many different ways can she rank those locations? So how many total places is she looking at?
5 locations.
5. So if I chose one for this thingy, then I have how many left over?
4.
How many left over?
3.
Now,
1.
no, why did I do that? No, that's not it. Okay, so we're just multiplying those guys. You can actually do the multiplication. For the smaller numbers, it's easier to just do that multiplication out. Type 5 times 4 times 3 times 2. If I ask you to do like 20 factorial, yeah, you're probably going to type that one in the calculator. Whereas this is easy to type in.
It's 120.
120? that it? I don't know what I typed in. Oh wait, I'm just starting to write things out in case I forget something. You gonna go to the next slide? Okay, what if she only cared about the top 3 locations? Okay, we're only gonna rank those top 3.
But this is without repetition?
Yeah, this is without
Then we
repetition.
can't do our 5 factorial.
We can't do our 5 factorial.
It's easy when I have a copy behind me.
Thank you.
Hey, you made a whole
Hey,
billboard
this
for you and
is
your
wide
family.
again.
That's okay.
Oh, okay. Okay.
Back page shouldn't have it. They made a whole billboard for you and your family in the library. You have to see it when you go to class.
Oh, is it really hard work?
Okay. So I still have 5 choices, 4 choices, 3 choices for my third thing. Okay. That is what we call the permutation piece of it.
That thing says We Heart Books and it's been up for about a month now.
Oh my god, Mom. I haven't seen it yet either.
And he just noticed it.
Okay. So,
Good job.
permutations are where we're not doing that whole factorial piece. Of course, we have to give you guys a gross equation for it, right? Because all mathy people, we just make gross equations. Okay? So what we're going to say for that, so we're going to be looking at that problem a lot, just to use it in the formula. Because that wasn't hard to figure out, right? 5 times 4 times 3, that was 60 total options. It wasn't gross. The formulas look gross, and I'm just sorry about that. This is what the formula looks like. So I'll write it out bigger. So we have in permute r equals n factorial over n minus r factorial.
So funny.
What?
The factorial.
And so loud.
N!
Ed is here.
That's what I'll say. Anytime I want you to do that, I'll be like, 4! Okay?
That'll help me remember it.
Okay. Try not to think about this gross formula. It's gross. It's not like, we'll do it using the formula instead of that easy, we just did 5 times 4 times 3. Okay? But that's what I always
You
do.
would walk in again and you'd be like, 4! Jake.
Okay, so suppose the business owner we're using the same problem. I didn't even change the problem. We're just doing those top 3 locations. So how many total places do I have? That's my n.
3.
No, that's what I'm trying to find.
This is 5.
So what I'm trying to do is 5p, I might have typed it all.
5P.
Did I type it? No.
No,
Okay.
just off.
5p,
Karen missed the blue
3.
balls yesterday. Blue balls.
Yes, we had to say blue balls a lot yesterday, and we got it. We still laugh every time. Okay, so n, my n factorial, I have 5 factorial. 5 over,
5 minus 3.
No.
Okay, so what that's actually going to look like, it's easy when you actually write it out. It still is easier if you get the concept of it instead of trying to remember the formula. Okay, so I have 5 times 4 times 3 times 2 times 1. On top, what's 5 minus 3? 2 factorial, which is 2 times 1. Hey, look, those guys crossed out. What did I have left? 5 times 4 times 3. That was the same thing we had on the last thing. It's just, hey, we have to make a formula for everything. Okay? So be comfortable using the formula. The formula is easier for larger numbers, like 5 and 3. No, those are easy ones.
See, that wasn't that hard.
No. But if you're doing like, I have 20 and I need to rank 19 of these thingies, like, that might be grosser looking. Okay, so that's where they're actually useful. Okay, so let's just do a couple of these, and then we can see why we have some of the rules that we made up.
Gross.
Okay, so 5 permute 5 is I have 5 factorial. 5. 5 minus 5 factorial. Okay, so I have to have 5 times 4 times 3 times 2 times 1
Choose 120 over.
You said that very
over
sing-songy.
0. Okay, over 0 factorial is always 1, so it's really just 120 over 1, just 120. Okay, So that is why they made the definition of 0 factorial equals 1.
What's the fee, got
Okay. 6 factorial, or 6 permute 4, I just want some practice, so I have 6 over 6 minus 4.
I can stand that if there are certain people, but
that makes no sense.
What
what?
makes no sense? This
My feet bother you.
Just
My
like
feet
some
don't bother
people's
me.
feet bother me.
Guys' feet.
If they stink or they look funny
What's
or
wrong with the guy's foot?
I don't know. Guys'
My dad
feet.
really
has
like
ugly
girls'
feet.
feet don't bother you though?
no, girls' feet don't bother me.
That's
Well,
weird.
unless they're nasty, feet.
Okay.
Some girls.
But
feet
like
bother
guys'
me.
feet
Okay.
don't bother me unless they're my dad's
Let's
feet
not feet.
usually, because my dad's feet are very gross.
Okay, so one of the weird tricks that I'm also going to show you, which is weird to see with just a 2, but whatever my bottom number is I'm going to write 6 times 5 times 4 times 3 times 2 factorial, and I'm not going to write out the bottom.
Why'd you say
Two.
2?
Well, okay, so 2 is a bad example. If you had a bigger number,
Then
it would be
cool.
useful. So then I can just cross that out, and I didn't have to write out. If I had 100 factorial, I'm not going to write 100 times blah, 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 blah. I'm just going to cross it out. So that's what's going to happen. They multiply to 1 and 1. So 6 times 5 times 4 times 3, 60 times 6, 360.
What did you learn today? All these exclamation points. Properly. Don't change
Yeah.
it.
I'm not changing it.
Sarah. Can't keep my hands to myself.
Can't keep my feet to myself.
Oh, God. Like him and Brandon, like what did you
You
guys
ready? Are you done?
Yeah. Him and Brandon like tackled me last year.
'Kay.
And like put me on the ground and then like shoved me
That
in the
is gross.
corner and like attacked me with their feet.
Oh,
Um,
I would cry.
So permutations
I almost did.
are about like first, second, third, or king, queen. Those are what permutations are about. Sometimes though, I'm going to do combinations. So an example of combinations is I want to pick 2 materials for a new dress. So how many possibilities can I possibly have? So I don't have enough numbers for us to actually figure out anything. Does it matter if I had like red and yellow or yellow and red?
Yes. No.
No, like if I'm just
Same
like,
thing.
yeah, it's the same thing. That when they're the same thing, if it's not different based on red, yellow, red, that's a combination. Okay, so if order doesn't matter, we have a new gross formula. Okay, combinations just don't care about order. So an example of this, so we're just going to list out the different possibilities and just kind of see how the lists are different. Given A, B, C, D, list the permutations and order and combinations for selecting 2 letters. So selecting 2 letters, I could have A, B, A, C, A, D, B, A, B, C, D, B, D, same thing with C, C, A, B, C, B, D, D, B, A, D, B, D, C. I can't say it. Okay, whatever. Okay, so then what are your combinations going to look like? Well, if I had the same list, but AB is the same as BA, CA is the same,
And
CE, and then those are all already picked here. Okay, so for my permutations, I had 12 total permutations. My combinations, I had 6. So kind of like, how is that different? So we're going to use another rule for it. When we ignore order, okay.
It's cold in here, man.
I was really hot the last couple days. Or I was cold, so I needed to. I don't know.
You're so heated.
Monday it was 80 degrees in
And
here.
it felt
Funny.
great.
Heated. He was very heated.
Okay, so our gross formula for in choose are, so combination is,
What the?
so combination. See, doesn't this look gross?
Why do you hate us?
I told you this, I just do. Okay.
Because we don't have any friends.
The way we read this is we say in
Yeah, that was
choose
mean.
are.
That was hilarious.
That was mean.
Jake, you have friends. Calm down.
Okay, so this is read in choose are. There's no fancy things for the permute, but the C means combination, the P means permute. Chooser, we're choosers. Okay, so then the way it reads is combinations of R objects selected from in objects. I don't think anybody ever says that. We just like all those mathy people just say in chooser. Okay, still, the reason why we do it is it's shorter than listing all those possibilities.
Can we stop now?
No, we're gonna do a few of them, but then this is like the last sort of thing we're doing. How many combinations of 4 objects are there, taken 2 at a time? So what that looks like is I do 4C2. So I have 4 factorial. I have to write the factorial. Then I'm gonna have 4 minus 2, also factorial, over my R factorial, which is again my 2. Okay, so what that dude looks like, so just kind of simplify out as much as possible. I would have 4 times 3 times 2 times 1. 4 minus 2 factorial is also 2 factorial. So I'd have 2 times 1 times 2 times 1. So those ones cancel out. So then I would have 12 over 2 is 6. So those are how your combination-y parts work. I want to go over, there's this trick that's kind of in the book, and this is a nicer way to remember it and actually use it. Because if you're ever like, come on this on a test, like I'll show you how to use it on a calculator. You're going to be like, okay, let me find the button on my calculator. But what you're really going to do is, okay, I feel like I should be able to probably figure that out if it was small numbers, like that ABCD thing. Otherwise, you're just going to be like, oh, whatever, next question. And I don't want that either. So the trick to remember it is use that permutation. So what we're going to do is we can also, so this was the gross formula way. So if I'm taking 2 objects at a time, I have 2 options. How many things did I have for my first choice? 4. How many for my second choice? 3. What I'm doing then is dividing by whatever this number is, divided by 2 factorial. Okay, I didn't have to think about the gross formula. I just basically skipped right to this step. Okay, so you do how many choices you have divided by how many choices are you trying to find. Really? Like I was thinking about taking one of my classes outside this afternoon. No?
Do it.
Okay.
Why not?
Take your geometry class outside.
That was what I was going to take outside.
Why? Why would you not take them
Because she
outside?
doesn't.
No, wait, what did the weather in the room have to do with taking them outside?
I don't know. I think he wants to. I don't know. My window's open, and he keeps like glaring at my window.
I'm sitting under a fan.
Come on, click. I've clicked you. Okay. So the last thing we're gonna do is what about if we have combinations of different things? So in a club there are 7 women and 5 men. A committee of 3 women and 2 men is to be chosen. How many different possibilities are there? So the first thing we have to decide is the order of these things matter. Things, sorry. Whoops, that wasn't the one I wanted to. I don't know what I typed here. So, whoops. So what we're going to do is we're going to find whatever number it is for these combinations, and then we're going to multiply them. We're basically going to find them separately so it doesn't get like all jumbled together and gross. Okay, so a committee of 3 women, I don't care. I don't have like a president, vice president, anything there. They're all equal. They're all the same. So that means I'm going to use my choose or my combinations. So I use 7 choose 3. So 7 choose 3. Remember, I'm going to do it a couple different ways. I'm going to do like one of them one way and then one of them the other way. So 7 choose 3 is if I wanted to do it like using that permutation piece of it. If I need 3 spots, how many choices did I have for my first spot?
7.
Next spot,
6.
next one,
5.
over,
4.
how many things were I trying to find?
3.
So I do 3 factorial on the bottom.
3.
Gross, don't do that. Okay, so I don't know what that number is, so we'll figure out what that number is. Stop that. 5 choose 2, I'm going to use the formula looking piece of it. So I'm going to do 5 over 5 minus 2 factorial, 2 factorial. I can't just not say it. It's not in my mathy nature. Okay, so then I'm going back to say, okay, I have 5 factorial. Yeah, that I have to say everything semi-properly. So then if I this would be 3 factorial. So 3 times 2 times 1 times 2 factorial, which is my 2 times 1. I'm gonna mark off those 3 times 2 times 1. So then I would have 5 times 4. I was really confused because I'm like, these aren't the same numbers, but I forgot that I'm actually doing different things. So, okay, so I'd have 20 over 2, which is just 10. Did you guys do this piece in the calculator at all for us? No?
What the hell are you fucking me?
Because you have the calculator.
Jake.
10 over something. I don't know.
You're
Oh, yeah.
ridiculous.
Okay. 210 over 6, which is 35. Okay, so now when I'm trying to actually figure out the possibilities, we're multiplying. We're using multiplying in there. So now I'm going to do 35 times 10 is 350. Okay, don't try to write it all out in a line because it's gross. You need to like flip them upside down.
No, I'm just doing this.
Fine. Okay, so just all your rules that we just learned, maybe, were your combination or your fundamental counting rule, your combination, and your permutations. So, just in case you didn't get your formulas written down, those are your formulas. And
That's stupid. God.
so there you go.